Okay, now we've got inverse trig functions, and hopefully you remember inverse trig functions from when you took trig or pre-calculus. But here it is. So for sine, here's your theta right here. Sometimes they refer to that as the u, and then they put the derivative of u. Since we usually refer to this thing right here as the theta, I go ahead and say it this way. So you take derivative of theta over the square root of 1 subtract theta squared. That's the sine, the inverse sine derivative. So dy dx is equal, there's the theta. So it's the derivative of, so 2 times negative 1, that would be negative 2x to the first over square root 1 minus negative x squared, and then you simplify that further. You can put the negative sign in front from the negative 2x. Now this negative, when it's squared, it will be positive, so we still put 1 subtract, and then that becomes x to the fourth, like that. So this right here is the derivative of this inverse sine. So the inverse cosine is almost identical, except for you take the negative derivative of the theta. So dy dx, so we take the negative of the derivative, which would be 5 times 3 is 15, and then 5 subtract 1, so that's 15x to the fourth. Square root of 1 subtract 3x to the fifth, and then we square that. Remember, the 3 gets squared as well. So negative sign up front, 15x to the fourth over 1 subtract 9x to the 10th. Okay, so that's cosine. I'm not going to do, at least in this video, the inverse of cosecant, secant, or cotangent. In my trig courses in college, we didn't do a lot of that. I might come back and do one of those. All right, so here's our theta, and the tangent, the inverse tangent is the derivative of theta over, the radical sign goes away, and this is now a plus sign down here. So dy dx equals the derivative of 4x to the fourth is 16x cubed over 1 plus theta squared, and then we simplify that further. Four squared is 16, and then using the laws of exponents, x to the fourth squared, you would multiply the power, so that would be x to the eighth. So this right here is the derivative of the inverse tangent. All right, that's it for this one.